Designated as minor planet 134,340, Pluto, along with one Ceres, is the largest and second closest dwarf planet in the solar system. It is the first planetary object in the Kuiper belt and is more massive than every other dwarf planet in the solar system except for Eris. Size comparison. Pluto is the largest dwarf planet at 1,477 miles, 2,377 kilometers in diameter. However, since Eris is 27% more massive, along with other smaller bodies being named and having similar awkward orbits with the object, it had caused it to be reclassified by the IAU made in 2005. Since there were more and more spherical bodies being discovered with the advanced technology of telescopes and other instruments, astronomers had decided to make a criteria and change the definition of what makes a planet. There are three criteria for a planet. 1. It has to orbit a star. 2. It has to have enough mass to assume hydrostatic equilibrium by gravity. And 3. It has to clear the neighborhood around its orbit. Pluto failed to meet the third criteria of being a planet and causing itself to be reclassified as a dwarf planet on August 24, 2006. Pluto is 1/5 Earth's width, 6.3% the gravity, and around 18% to 19% of the diameter. Also, Pluto is significantly less massive, only being 0.22% of the mass of Earth, and also being 5.4 times smaller in diameter and 154 times less when compared to volume. Time. Pluto takes approximately 248 Earth years to make one orbit around the Sun. With an average distance of 39.5 AU from the Sun, the distance is 3.7 billion miles, 5.9 billion kilometers, with the perihelion being 29.658 astronomical units, or roughly 2.73 billion miles, 4.4 billion kilometers, and the aphelion being 49.305 astronomical units, or almost 4.59 billion miles, 7.38 billion kilometers away. It would take light an average of 5.5 hours to travel from the Sun to Pluto. However, light would not travel around Pluto in a closed loop and instead travels in a straight line. Discovery. Pluto was discovered on February 18, 1930 by Clyde W. Tombaugh, an American astronomer at the Lowell Observatory in Flagstaff, Arizona. At that time, it was first considered as the ninth planet from the Sun. But in 2006, the IAU found out that Eris was significantly more massive than Pluto and both of them were too small to clear their orbits in the Kuiper belt, eventually making the decision to reclassify it as a dwarf planet without further investigations. Pluto was named after an 11-year-old girl named Nisha Burney of Oxford, English by suggesting that the name was related to the Roman god of the underworld shortly after its discovery. The name was officially given on May 1, 1930 to honor Percival Lowell, the astronomer that initiated the search for a planet beyond Neptune, as the first two letters of Pluto and his initials. Planetary structure. Pluto's atmosphere is a thin, tenuous layer of gases primarily composed of nitrogen, N, subscript 2, with minor amounts of methane, CH, subscript 4, and carbon monoxide, CO, all of which are vaporized from surface ices. The surface pressure is approximately 1.0 Pascal, 10 microbars or 9.87 multiplication 10 superscript minus superscript 6 ATM as measured by the New Horizons spacecraft in 2015, which is roughly 1/100,000th of Earth's atmospheric pressure. This pressure has slightly decreased to about 0.91 pascals, 8.98 multiplication 10 superscript minus superscript 6 ATM by 2020. The atmosphere extends to a height of about 1,700 kilometers exobase, and due to Pluto's low gravity, it is much more extended in altitude than Earth's atmosphere. The atmosphere exhibits strong seasonal changes driven by Pluto's highly elliptical orbit and axial tilt, causing its surface ices to sublimate when closer to the Sun and condense when farther away, leading to a temporary atmosphere that expands and collapses. Methane acts as a significant heating agent, contributing to a greenhouse effect that causes the temperature to rise with altitude, reaching about 110 kelvins, minus 163 degrees Celsius, at 30 kilometers before decreasing. The surface temperature ranges from 40 to 60 kelvins, minus 230 to minus 210 degrees Celsius. The defining feature of Pluto's atmosphere is its multi-layered haze, which extends to altitudes over 200 kilometers and consists of complex, non-volatile compounds like acetylene C, subscript 2H, subscript 2, ethylene C, subscript 2H, subscript 4, ethane C, subscript 2H, subscript 6, and hydrogen cyanide, HCN, formed by the interaction of atmospheric gases with high-energy radiation. These haze particles are responsible for the blue color observed in images and play a crucial role in the planet's energy balance by absorbing sunlight, cooling, and radiating heat. The haze layers are not continuous, with horizontal extents of at least 1,000 kilometers and vertical spacing of about 10 kilometers, and are denser in northern regions. The upper atmosphere is colder and more compact than pre-encounter models predicted, which suppresses the expected hydrodynamic escape of gases into space. Despite its thinness, the haze is dense enough to scatter light significantly, allowing features on Pluto's night side to be imaged. Observations from the James Webb Space Telescope have confirmed that the haze particles rise and fall with thermal cycles, a phenomenon not seen elsewhere in the solar system. The atmosphere is also notable for its chemical complexity, with the concentration of methane being significantly higher than expected based on surface ice composition, a discrepancy that remains unexplained. Pluto has 5 known moons: Charon, Nix, Hydra, Kerberos, and Styx. Charon is the largest, with a diameter of about 1,212 kilometers, making it roughly half the size of Pluto itself, leading some scientists to describe the Pluto-Charon system as a binary dwarf planet system. Charon orbits Pluto every 6.387 Earth days, and due to tidal locking, the same side of Charon always faces Pluto, just as the same side of Pluto always faces Charon. The other 4 moons, Nix, Hydra, Kerberos, and Styx, are much smaller and irregularly shaped. Nix and Hydra were discovered in 2005 by the Hubble Space Telescope. Nix has an estimated size of about 49.8 by 33.2 by 31.1 kilometers and orbits Pluto every 24.85 days. Hydra, the largest of the small moons, measures approximately 50.9 by 36.1 by 30.9 kilometers and completes an orbit every 38.20 days. Kerberos, discovered in 2011, is about 19 by 10 by 9 kilometers in size and orbits at a distance of about 57,783 kilometers from Pluto. Styx, the smallest and farthest moon, was discovered in 2012 and has an estimated size of 16 by 9 by 8 kilometers, orbiting at a distance of about 26,505 miles, 42,656 kilometers, from Pluto. All of Pluto's moons are believed to have formed from debris resulting from a massive collision between Pluto and another Kuiper belt object early in the solar system's history. The moons are named after mythological figures associated with the underworld: Charon, the ferryman; Nyx, goddess of night; Hydra, the multi-headed serpent; Kerberos, the three-headed dog; and Styx, the river of the underworld. The entire moon system is thought to be in a chaotic dynamical state, with the smaller moons rotating rapidly and unpredictably, which is unexpected given the gravitational influence of Pluto. Pluto's crust is composed of a layer of various ices, primarily nitrogen ice, with giant mountains formed from water ice and traces of methane and carbon monoxide (CO) ices. This icy crust is part of a complex internal structure, with a rocky core surrounded by a mantle of water ice, and the surface ices forming the outermost layer that the crust is cut by numerous fractures, which are believed to result from the stretching of the surface, providing evidence for a subsurface ocean beneath the icy shell. The crust is also known to be geologically active, with features like glaciers of solid nitrogen flowing from regions such as Sputnik Planitia into adjacent areas, and the surface of Sputnik Planitia itself being exceptionally young, less than 100 million years old, due to ongoing geological processes like convection and viscous relaxation. Pluto's mantle is believed to be composed primarily of water ice, surrounding a rocky core. This icy mantle makes up a significant portion of the dwarf planet's mass, with some estimates suggesting it could be about 50% of Pluto's total mass. The mantle is thought to be thick and may even contain a thin liquid ocean beneath the frozen surface, although this remains a subject of scientific investigation. In addition to water ice, the mantle and surface are coated with more exotic gases such as methane, nitrogen, and carbon monoxide. Pluto's core is believed to be rocky, composed of silicate rock and metals, and is thought to have settled into a dense central region due to the planet's internal differentiation. This core is estimated to be about 1,056 miles, 1,700 kilometers in diameter, making up roughly 70% of Pluto's total diameter. The core's temperature is predicted to be around 1,000 kelvins or 1,346 degrees Fahrenheit, approximately 730 degrees Celsius, a result of heat generated by the decay of radioactive elements and the energy from the large body impact that formed its moon Charon. This internal heat is sufficient to have melted the surrounding ice during Pluto's formation, allowing the rock to separate and sink to the center. The core is surrounded by a thick mantle of water ice, and there is strong evidence suggesting the presence of a subsurface ocean of liquid water, potentially 100 to 180 kilometers thick, located at the boundary between the core and the mantle. This ocean may still be liquid today, driven by ongoing internal heating. The core's high density, measured at 1.853 plus minus sign 0.004 GCM superscript 3, supports the model of a differentiated interior with a rocky core. It is currently unknown whether Pluto possesses a magnetic field, but its small size and slow rotation strongly suggest it has little to no magnetic field. Unlike planets with intrinsic magnetic fields, Pluto lacks a global magnetic field, which means it does not have a magnetosphere to shield its atmosphere from the solar wind. Despite this, Pluto has a significant atmosphere composed primarily of nitrogen, methane, and carbon monoxide, which extends up to 1,000 miles, 1,600 kilometers above its surface. The interaction between Pluto's atmosphere and the solar wind creates a comet-like environment, where neutral particles escape and become ionized, leading to phenomena such as the emission of X-rays, which was first detected by NASA's Chandra X-ray Observatory. Early history formation. Pluto was formed over 4.5 billion years ago and is classified as a dwarf planet located in the Kuiper belt, a region of the solar system beyond Neptune populated by small icy bodies. It is thought to be a residual planetesimal, a remnant from the original protoplanetary disk around the Sun that failed to fully coalesce into a full-fledged planet. According to current theories of solar system formation, Pluto formed in the outer solar system, where the solar wind had less impact on lighter elements, allowing ices and gases to coalesce around a rocky core. The discovery of other large objects like Eris in the Kuiper belt, which is similar in composition and size to Pluto, supports the idea that Pluto is representative of a class of bodies that formed under comparable conditions far from the Sun. The formation of Pluto and its largest moon, Charon, is explained by a kiss and capture mechanism, a model that suggests the two bodies initially collided and briefly stuck together, rotating as a single object before separating and remaining gravitationally bound in a binary system. This process differs from typical planetary collision scenarios like hit and run or graze and merge. The leading hypothesis for the formation of the Pluto-Charon system is that nascent Pluto was struck by another Pluto-sized object, with the combined material forming Pluto and the debris coalescing into Charon. The heat from the impact and subsequent tidal forces likely played a crucial role in shaping the geological features observed on Pluto's surface today. Pluto's current position and orbit are believed to be the result of Neptune's early migration outward through the Proto-Kuiper belt. This migration, potentially triggered by a wind resonance between Jupiter and Saturn, caused gravitational interactions that scattered objects into chaotic orbits, placing Pluto and other Kuiper belt objects into their current positions. Pluto's orbit is highly elliptical and inclined compared to the major planets, which is consistent with its long and dynamical history.